Welcome to another edition of Blunderverse. My name is Neil Shaw, editor of Blunderverse. Blunderverse's mission is to capture and share with you some of the latest events in astronomy, wherever opportunity strikes. Today I caught up with Peter Wheeler, Outreach Manager from ICRAR, the International Centre for Radio Astronomy and Research, and also Dr. Megan Argo, Research Fellow in Astronomy. Both Peter and Megan were on site at the European Space Agency's radio telescope facility at New Norcia, located at Western Australia, promoting radio astronomy during National Science Week 2010. Here's Peter.
So the exhibition itself, we've called it Tuning In, for the radio astronomy connotations and also the connotations of people getting a better understanding and a better feel for radio astronomy and science. It involves a number of pieces of equipment, some that people wouldn't have seen before and some that people would have seen before but used in a slightly different way. There's three pieces of equipment. The first is a dish. It's a satellite dish that you might use for picking up TV stations and things like that, that we've outfitted for a bit of radio astronomy. It's called a TRT, a tiny radio telescope, or at least that's the name we've given it. And really that's equipped to detect the sun. It's not big enough to detect, anything further than the sun or smaller or a lower signal than the sun, but we can pick up the sun. The second piece of equipment we've got is called a dipole. So it's a slightly different type of antenna. It observes in slightly different frequencies and wavelengths. It's still observing in the radio, of course, and that's part of something called the Murchison Wide Field Array. And this dipole was actually out in the Murchison being used for actual radio astronomy. So it's a working piece of equipment that we've pulled into this mini exhibition.
Right, and so the Murchison is sort of northwest of WA, Western Australia. It's about 200 kilometres east of Geraldton?
Yeah, somewhere in there. So it's in the Midwest region. It's between Meekatharra and Geraldton. It's a very radio-quiet area, which is very important in terms of radio astronomy because humans, obviously we put out a lot of radio interference from mobile phones and for radio stations and things like that. So in the radio astronomy world, and particularly in Australia, the Murchison's very important. And is currently hosting some projects and will potentially become the core of something called the Square Kilometre Array project if Australia has chosen to host that project. And
what's the status of that? Because I've heard that it's a pretty big project. It's national size.
It's enormous. It's enormous. I mean, if you know of other science projects, things like the Large Hadron Collider, this project is of that scale. There's 20 countries around the world involved with this project. It will be the biggest radio telescope ever built. It will operate for the next 50 years or more, and it will do some very important science and help scientists and everybody better understand the beginnings of the universe and how it's evolved since then. Currently, a few years ago, the selection process of which site was going to host it narrowed down from 4 places in the world to 2. Those places are Southern Africa and Australia and New Zealand. So we're about probably 18 months away from a decision, so we expect that decision hopefully in early 2012 as to which country will actually host the project. But it is an international project, so hosting it is one aspect of it. Irrespective of whether it's here on Southern Africa, all of those countries are still involved.
Okay, who actually gets to decide on?
It's a very good question. So there's a body called the SBDO, the SKA Programs Development Office, and that's based in Manchester in the UK. And currently they're actually deciding on the decision process, setting the criteria, and also working out who is going to make that decision. So they'll probably create an independent entity, a collective of people to make that decision.
Okay. And presumably it's going to be based on science rather than anything else.
Again, a very, very good question. So for us and our bid, the science is extremely important, and we see that this instrument needs to be located in the place that will generate the best science and the best outcomes. We have a pristine radio-quiet environment for this instrument, which means we can get the best science out of it. But there will be other criteria involved as well. We'll have to wait and see exactly what those criteria are.
Okay, well, I'm certainly looking forward to 18 months ahead, and I certainly wish Australia well in that regards.
And it has been a long process. Projects of this scale take time, but we are getting to the thin end of the wedge with that decision, and then finally the final design and the rollout with an expected operational date of around 2025. The SKA will have about 3,000 dishes in it. A lot of people think that the square kilometre comes from the footprint, and that's an easy assumption to make. That must be the footprint under the telescope, but that's not the case. The square kilometre in the Square Kilometre Array comes from the collective surface area. So this dish is a 35-metre dish, and its surface area is the receiving area for the radio waves. The SKA will have about 3,000 dishes, 12 to 15 meters in diameter, spread across the entire country, and all of those dishes added together, all of those surface areas will equate approximately 1 square kilometer, which gives you a 1 square kilometre eye, a radio eye on the sky, and that's essentially what it's doing.
I believe that even New Zealand may possibly host some of the telescopes.
Absolutely, absolutely. So New Zealand came on board with the Australian effort last year, so now we have a collaborative bid, and yeah, the plan is for New Zealand to host some of those array sites. And New Zealand has also, recently started doing some interferometry with some Australian sites. So something called the VLBI, the very long baseline interferometry observations, where dishes across Australia and also into New Zealand work together in what's called an interferometer to observe something. And the first dish for ASCAP, which is the Australian Square Kilometre Array Pathfinder, which is the test bed, or for the Australian bid, I suppose, is already up on site in Murchison, and that contributed to those VLBI measurements. We should have 6 of those dishes by the end of the year there, and 36 by the time ASCAP is fully built.
That's fantastic.